We've previously looked at surface area and volume of prisms, then again as cylinders, which is really just a circular prism. But now we have pyramids, and so we need to think about what a pyramid is. So when we say pyramid, this is usually the um, image that a lot of people think of. And notice it's kind of like a prism, but all these triangles, they go to the same position. They all converge to the same point. So it's not like a triangular prism where the height just goes straight up for all of these. And so um, we have two triangular bases that are the same area. This here, this pyramid, all the heights converge to each other. So the formula is going to be a little bit different for surface area and for volume. So for the surface area, um, there's a couple different ways to think about this. I mean, we have these triangles, um, and so these we could take the triangle, the surface area of this triangle, surface area of this triangle. So these four triangles, add them together, and then do the surface area of the base and add them all together. What we could also do is look at this formula. So the surface area is equal to 1/2 PL plus B. Okay, so notice the capital letters here. So this capital P stands for perimeter, and specifically the perimeter of the base. This capital B stands for the area of the base. So this is our base down here, which in this case is a rectangle. And so what we want to do is we want to find the perimeter of it, and that's capital P. We want to find the area of it, base times height, which is capital B. And then we have this L. So this L is the slant height. So typically we measure height perpendicular to the base. So if I want to measure the height of this pyramid, it's going to be perpendicular to the base. Well, slant height is the distance upwards. So probably just want to use a straight line for this one, right? So imagine it's like a hill and you're walking up. So I'm going to be walking up this distance. That's my L. When we see some examples, it might make a little bit more sense. Just some different variables, some different ways of looking at this that really is not all that difficult once you start seeing it in action. And then the volume, we've typically looked at the volume being the area of the base times the height. Here, it's similar to that. We have the area of the base, which is again capital B, times the height, but we're going to multiply this by a third. So I take the area of the base, multiply by the height. So height is, again, perpendicular to the base, so straight up. And we just take a third of that. So let's look at some examples here. So I want to find the surface area here. So I know that the surface area is going to be 1/2 perimeter of the base times the slant height plus the area of the base. So this is 1/2 perimeter is 4 plus 4 plus 4 plus 4. So that's 16 times the slant height, which is 5.4, plus the area of the base, which is 4 times 4, which is 16. And we just have to combine them together. So half of 16 is 8. We can multiply that by 5.4 and then add 16. So we get 59.2 feet squared. And that's nice when they give you all this information. Same with number 2. We have 1/2 perimeter of the base times the slant height plus the area of the base. So we have 1/2 6 plus 6 plus 6 plus 6. 24 times the slant height, which is 7.6, plus the area of the base, which is 6 times 6, which is 36. So we're going to have half of 24 is 12 times 7.6 plus 36 is going to give us 127.2 yards squared. Then we have the volume. So volume, like we said, is going to be 1/3 the area of the base times the height. So this is 1/3 the area of the base here is 4 times 3, which is 12, times the height, which is 4. So this is going to be 1/3 of 12, which is 4. So 4 times 4 is 16 inches cubed because we're talking about volume. And then for number 4, we have 1/3 area of the base times the height. So this is 1/3 of 25 times the height, which is 8. So 25 times 8 is, well, that's 200. Now we can't divide that by 3, so we could just leave it as a fraction 200 over 3, which I like. Or you can round this off and say this is 66.67 feet cubed. And that's it, but you might have some more challenging questions, such as, ooh, I don't know, what if I ask you to find the volume of one of these? Well, then, if you think about it, you don't have the height. So what you're going to have to do is give yourself a little right triangle in here and use this as the hypotenuse and these two as the legs. So you have a squared plus b squared equals c squared. So think outside the box for something like that. You want to give a two-dimensional picture for this three-dimensional problem. It can easily be done, but make sure you know these formulas and watch out for your areas and units.